Hey guys, let's go ahead and get started. So this is objective 4-1.2. These are the notes that you'll be taking for these tonight instead of doing your homework. The whole idea behind doing this is for you to be able to work more at your own pace in class. And what we're doing is presenting the opportunity to try to do the notes at home. So when you think about what your note page should look like, I'm going to scroll over here. And you're going to set your note page up just like you have been doing normally with the objective here at the top and then the actual objective name. Students will be able to solve systems by graphing, and then your name, the date, and your advisory. The only main difference that you're going to do here is for example 1, you're going to draw a line, you'll see I'm highlighting it now, down the center of your page. And what you're going to be doing is everything on the left hand side, so all over on this side here, all of this is where you're going to take your notes during the homework section. And you're going to leave the right hand side, or this side over here, you're going to leave this blank over here. This is just going to stay blank, so that if we need to take notes during class, and if you don't end up testing out some of these examples, this is where you'll be doing it in class. So when you come to school every day, the right hand side or the purple side should be blank. The green side should be filled in with the note that you took during this this section in class, or section in your notebooks. So I'm going to erase this green stuff here, and what you'll see is I've started to do example 1 down here on this left hand side. So if I scroll back over to example 1, which we're going to start doing here in just a second, make sure your paper is headed with the objective. Students will be able to solve systems of equations by graphing. And example 1, feel free to pause the video if you need to, if you need more time to write this stuff down, is here. I'm going to continue doing it just like this on the PowerPoint slide, and you guys can go ahead and copy down the coordinate plane in your notebook. Again, you will see that I have done that up over here on the left side. I'm going to show you. So here I've got the coordinate plane in the notebook, kind of giving you like a visual representation of what this should look like. So here I've got, my coordinate plane, and I'm going to show you how to solve it. All the notes should be taken again on the left side of this page. So let's just go ahead and start with example 1. So what do we mean by a system of equations? So system of equations basically means, it's a fancy way for saying more than one. So the systems here, this whole word, all that means is just saying quote unquote 2 or more equations. That's all that means. So basically what we're doing is we're taking what we already know how to do graphing today, these equations, and we're doing them 2 or more of them on the same coordinate plane. So for example, and you're going to write as I write, take this first equation, and the first equation we're going to use is going to be, let's see, it's going to be y is equal to 2x plus 1. So here I'm going to write y is equal to 2x plus 1. You're doing this in your notebook. So y is equal to 2x plus 1. I know from what we've already done in class that this right here, this positive 1, is my y-intercept. So I'm going to graph this red line with a point starting at positive 1 on the y-axis. So if I look here, I'm going to plot myself that positive 1, which is the y-intercept. To get to the next point, I look over at the slope. The slope is going to be 2 over 1, which means I'm going to have a vertical change of 2 for every positive increase in the x. So that means from the point I have now on my y-axis, I'm going to go up 2 and then over 1 to the right. So you see I have a vertical change of 2 units, positive 2 units, and then over 1 here to the right. And I can continue that pattern, up 2 over 1, up 2 over 1. And if I go ahead and I connect these dots with a line, which is what you should be doing right now, we're going to go ahead and say this is my red line. And actually, let me just try to draw this one over again. I don't like how that one came out. Not a big fan of this. So here's my red line. This is y is equal to 2x plus 1. 2x plus 1. And so I know that there are infinitely many solutions on this one line. any point that is on this line is a solution. So right here, this -1, -1 is a solution, -2, -3 is a solution, -3, -5 down here is a solution. All these points and all the points in between them that fall on the line are solutions of that line. But remember, we're trying to find solutions of a system of equations. So I'm going to go ahead and do a blue line here, and we're going to add another equation. So I'm going to add the equation y is equal to 1/2 x, right as I do. Y is equal to 1/2 x minus 2. And I'm going to do the same thing before I graph this equation, starting at the -2 on the y-axis, because that is my y-intercept found here. And the slope is up 1 over 2. So it has a vertical change of +1 and the y-axis, and then +2 for the x. The rise over run is 1 over 2, 1 over 2, and the pattern continues. Here I see, if I were to go ahead and graph this line, let's go ahead and graph this line really quick. If I graph the line, when I graph this line, I'm going to adjust it just a little bit. Like, how does he do this? No one knows. It's secrets. If I can actually get it to move. Maybe I don't even know how to do this. There we go. When I graph this line and I adjust it, what I notice, I've circled this in blue here, is I see that even though I've got infinitely many solutions on the blue line, all of those blue dots are solutions for the blue line, but because I'm finding solutions to a system of equations, that means this point here, where these two lines intersect, the red line and the blue line intersect, that is a solution to the systems of equation, the system that I have here. And that ordered pair is -2, -3. So that means, let me write that down here because this is really important. So that means here at -2, -3, the two lines I'm drawing, or that one system, the two lines or the one system, intersect at -2, -3. Where they intersect, or the intersection, I'm going to write that in my notes here, the intersection of the two lines is the solution to the system. Okay? Where the system, remember, is two or more lines together. So what that's saying is that that one point, that -2, -3, is the solution to this system. We're going to talk more about exactly what that means here in just a second.